Thank you, Scott. Hello, everyone. Thank you for joining the EcoCast today. And today I'm going to talk a little bit about the options you get with hyperconvergence. Because oftentimes we get into a situation where we try to stick with one particular architecture, but then we realize that that architecture is not a panacea and there should really be some flexibility. So StarWind decided we're not going to provide just hyperconvergence or just storage. We really wanted to turn into a one-stop virtualization shop and provide all the necessary building blocks for your IT infrastructure. And today we're going to talk a little bit about them and how they kind of fit together, how they complement each other, and what is peculiar about the StarWind approach, and also about what we do. But before we begin, just a small dive into our history. So why is StarWind doing hyperconverged? Why is StarWind even doing what it's doing a part of hyperconverged? And we've got our small timeline here with things we've done in the past and things we are going to do. And originally, StarWind started all the way back in 2009 as StarWind Software. Earlier, you could have known the company as Rocket Division Software. But in 2009, we got a whole separate storage-focused company, which was the first vendor ever to introduce hyperconverged storage for Hyper-V without resorting to virtual machines. So the storage hypervisor was actually running inside the operating system and not as a virtual storage appliance. And since that, we really started exploring that approach. We've seen that the market has grown all the way to hyperconvergence and all these events with multiple vendors. So we're glad that the experiment we took back there and our vision aligned with how industry wanted to go. So StarWind used to be a company working primarily for SMBs and filling their need of a small virtual SAN environment. But then we realized that a lot of our customers really like what we're doing because we allow to build a hyperconverged environment with a minimum possible number of servers without any additional hardware, and that started attracting them. So in 2015, we stopped selling just software and started providing actually pre-configured appliances to our customers. And this is how we roll right now. So right now, StarWind is a company which offers pre-configured solutions, and for customers who cannot get the pre-configured solution because of their high level of sophistication or they do have existing hardware, we would just give software. And this year we're jumping on the bandwagon of few new really attractive technologies. One of them is NVMe over Fabrics, which is an extremely fast way to deliver NVMe to your servers using 100 gig Ethernet mostly. And of course, it features RDMA. And also, we are planning to launch 3D crosspoint-based storage and hyperconverged solutions as well. Now, talking about our main product, the hyperconverged appliance. So, as I mentioned earlier, the typical problem we solve is very high complexity for smaller companies and for robo locations. Just to add that robo is remote office and branch office. And these companies typically have the same issues. Although they have different budgets and different approaches to IT, it's really the same pain. So they don't have enough people to manage the stuff. They don't really know how to virtualize at small scale because they're used to high scale virtualization, and they all have shrinking budgets. So SMBs don't have a budget yet, and the enterprises are always trying to cut some corners and see how they can optimize and get more with the same budget or more with even a shrinking budget. And we put together StarWind appliance to deliver a multi-hypervisor, hyper-converged environment, which is really turnkey. So by the time it arrives, customer doesn't even need to set up his storage or set up his cluster. Everything's pre-configured. So as soon as it arrives, he just needs to plug it into the network and outlet, and he can start migrating his virtualized or non-virtualized workloads instantly. And another key point about the hyper-converged appliance is that it's truly fault tolerant. So we're not making a big bet on massive scale out. With our target audience, the uptime and fault tolerance is a much bigger goal. So compared to traditional clusters, StarWind can withstand much more failures and is much more resilient. And let me just illustrate that with a few slides showing the principles of StarWind high availability versus traditional N+1 scale out clusters. So traditional scale out, let's say we have 16 or 12 nodes like in our particular case here, and they're all connected into one single cluster. A traditional architecture will not sustain more than 2 or 3 of these nodes going down. So the cluster will not go into degraded mode. It will instantly fail because data is written across all nodes, but losing more than 2 of them is like losing more than 2 drives in a RAID 10. So you just cannot withstand that. And with StarWind's grid architecture, what we do, we are actually building a grid where each node will be interconnected with another one, obviously using a switch. So the lines here just show the dependencies and how the data is mirrored between the nodes. And should even 50% of this configuration fail, StarWind can still withstand it. And in this case, StarWind will continue working. And you may say that, yeah, that's the same happens with RAID 10. If the write drives fail, technically you can continue working. But here's the thing. We continue working even if it fails really bad, let's say like this. So half of the nodes go down, and it can be wrong half of the nodes, and the cluster will still operate. It will still operate in a degraded mode. So you'll still have the compute resources and storage resources, and you can restore the workloads from the broken nodes from backup to the healthy portion of the cluster without any reconfiguration of the remaining nodes. And the system still runs and can still run virtual machines which were located on these nodes. So this is how we provide resiliency. And now we're getting back to the flexibility. I mentioned earlier that sometimes going with just hyperconvergence or just dedicated storage is not the best idea. So we decided that customers who really have a lot of data and their data set is growing much faster than their compute set is really a good candidate for not a hyperconverged environment, but rather a mixed environment, where some of the workloads are hyperconverged, but some of the workloads are stored on dedicated storage, which is more flexible in terms of scalability, and of course more flexible in terms of what we call independent scalability. To talk to that, in a hyperconverged world, if you need more storage, that means you have to add one more compute and storage node, and that node also drives your licensing cost up. And the ability to scale the storage and compute resources independently is critical if your storage resources are growing much faster than your compute, because obviously if you keep scaling with just nodes and add hypervisor licenses, those won't really be used in the environment. So the second product, which is StarWind Storage Appliance, really covers that area, and customers who want to scale these resources independently and want to get high performance from their storage across the board will really fill that gap with that appliance. And it will always integrate with StarWind HyperConverged Appliance into a single cluster. So they're all interoperable and they can really be built together as almost as Lego. And finally, you can never store your backup data in the same place where you store your production data. That is what's called a 3-2-1 backup rule, where you have 3 copies of your data on 2 different media, one of them being offsite. And StarWind's backup appliance helps customers to reach their RTO and RPO, or in our case, what we call, with help of Veeam, RTPO. So it's recovery time and point objective combined for their hyperconverged and storage environments. So this is a dedicated high capacity storage unit designed to work with your typical virtualized environments. And the main benefit it provides is the ability to get all your data and maintain at least 2 safe copies of it, one on-premise and one in the cloud. Additional asynchronous copy of the data can be added on the disaster recovery side. And of course, it provides all the snapshots, so should you decide you need to restore something, you can easily do that. And one more thing is the ransomware protection. So StarWind Backup Appliance can work as a virtual tape library. So compared to any NFS or SMB or any connected block storage, no ransomware can attack a virtual tape library, just cannot read tape. So as soon as you backed up your data to tape, you can be sure that if the data on the machine gets encrypted, you can still restore it, and there is no need to worry about the actual appliance because it's shielded with the protocol it's using to back up the data. And then even if the local hardware is down or compromised for any reason, there was always a cloud copy of the data, which allows you to restore not only to the location where you originally had the virtual machines or workloads, but also to any other location in the world. And finally, something Scott mentioned in the very beginning of his introduction is a really big thing for both SMBs and robos. It is a single point of contact support for all components of the solution. So be it hypervisor, storage, backup, or the broken hard drive, StarWind will be your single point of contact, never doing the finger pointing thing, always trying to help and always making sure that you're getting the best support. Because we are building these solutions, we are testing them, we do have a really short route to hardware support. So we always omit all the problems with the initial questions about trying to turn something off and turn it on again, and make sure that the diagnostics we have from the system are escalated as soon as possible. Now, talking a little bit about features we have in our appliances, there are multiple I'm not going to focus on all of them. I'm just going to emphasize on those which really stand out and which are a little bit different than ones provided by other solutions on the market as well as on these EcoCast. So first of all, what we do is fault tolerant. So your storage in the appliances is absolutely fault tolerant. There is no high availability, so there is no downtime if something goes bad, if something breaks. StarWind switches to another live set of data immediately. And there can be either 2 or 3 live sets of data, and they're all active at the same time. So it's all active fault tolerance, and all data and caches are mirrored. So the reliability and failover time are really, really great. Then another thing is the unified storage. So this works for both hyper-converged and storage appliance. We do not prohibit our customers to connect the hyper-converged appliance to their existing clusters. So we do support all the necessary protocols to share that storage we have outside of our own cluster to the existing infrastructure. And these days, it also supports the RDMA-capable protocols, which are ISER and SMB Direct. And we are almost done with NVMe over Fabric, so this will be added later this year, I think in summer. Now, talking about the features, and one feature which sets us apart from vast majority of hyperconverged offerings is the ability to scale up. So we would actually support adding more storage to individual hyperconverged appliance nodes rather than forcing customers to add another node and thus only scale out. So in our case, we do support both models, and we encourage users to mix them to maintain efficiency and maintain the flexibility to scale how they want it or how they need it, and not how they are forced to scale. Deduplication and compression are included with the appliance. For smaller environments, they make not so much sense, but in bigger environments, we definitely welcome deduplication, and the appliance can support both 4K inline dedupe and 32K offline deduplication. And just to add a little bit more about it, we do support a thing called snapshot tiering. So we would tier snapshots off to colder storage, and there is an ability to restore instantly from these snapshots. So the primary storage is never used for cold data. We try to dedicate the primary storage for just the hot data and make sure that the latency and the capacity are maintained at best point. And finally, a thing we are actively expanding right now is cloud storage tiering. So we do have an option to connect the hyperconverged and storage appliances to cloud to offload the cold data transparently from on-premise to public cloud, without actually spoiling the experience on the application side. So to the applications and to the virtual machines, storage will just expand, and we will maintain all the hot data on premise, and all the cold data will be offloaded to AWS or Azure, and then it can be retrieved from there as soon as it's needed, basically operating with 3 tiers. One would be local flash, one would be local nearline SAS, and one would be the cloud. Basically expanding the usable capacity up to petabytes with single unit installed and without any rack space occupied. And one more interesting thing about cloud economics is that you only pay for what you're using. So if you need, let's say, 100 terabytes of storage, but your starting requirement is just 2 terabytes, you only pay for 2 terabytes, and you never pay upfront, which is a really good thing in the world where we stopped paying upfront and really enjoyed the as-a-service model. And it so happened that I had my presentation just finished and opened the questions and answers session. So first of all, I would like to thank everyone for the time they dedicated to join us today. And I really want to get down to the questions because we have multiple. Yeah. Okay.
So we've got lots of questions for you, Max. One of the questions that we got is, how large can the cluster grow? How many nodes?
So technical limitation right now is 64 nodes. With this mainly comes from vSphere and Hyper-V, but the reality is our target audience would really try to keep the number of nodes down to, I would say, up to 5 nodes in bigger locations. So really the sweet spot would be in that part.
Okay. The other question is, how granular are the snapshot resources?
Okay, that would depend on the product we're talking about. So for the backup appliance, the snapshots would be based on how often Veeam, which is included in the backup appliance, takes them. And with the hyper-converged appliance, the file system we use has actually a very good side effect where each particular point in time is technically a snapshot. And we can set up to, I would say, 10 minutes to create a consistent snapshot of the environment. If necessary for certain virtual machines, these snapshots can be even more granular than that.
Another actually relatively basic question, but important, is who's the server you're using for your appliance?
So right now it is OEM equipment from Dell, and there is also our own componentry installed optionally. So that would depend on the configuration.
Perfect. Another question here, which file system are you using? Like, what's the underlying storage layout basically look like?
So there are several configurations that would depend on the config. So let's say a typical Hyper-V configuration, StarWind will operate on top of NTFS or ReFS. And if necessary, it can be coupled with the backend storage, which would operate, I would say, on the same principles. So the file system we use would be either a translation of NTFS all the way up to the virtual machine, so it would be CSVFS, and in case of our own file system, that would be the LSFS, which has the snapshots included and the 4K inline deduplication included. So virtual machines stored there technically also reside on CSVFS. It's just the translation layer within our storage, which would sequentialize their I/O stream from the virtual machine down to the disk and make sure that I/O blender is eliminated. So that devil will be in the details, and depending on the config, the let's say filling between the virtual machine and the hardware will be different. But ultimate answer, I guess, would be on top. Customer still sees either VMFS or CSVFS or highly available NFS or SMB3. So the virtual machine storage protocols and file systems remain intact for all hypervisors.
So the next question is, can you basically run this in a virtual machine, or do you have to buy the appliances?
So if you go to the cloud, you can actually virtualize everything, and StarWind can run as a cloud instance in AWS or at Azure. But on premises, we do need hardware devices. So basically, StarWind is if we take the most basic part of it, the StarWind virtual SAN, so it doesn't have all the management added, it's just the software-defined storage stack. It needs some hardware to run on, be it virtualized StarWind virtual SAN or running alongside with the hypervisor. It still needs some hardware to run. So I'm maybe not getting the question correctly.
Yeah, I think they're just asking if can you basically run. I guess the backup appliance, especially, could you run that as a virtual appliance rather than a hardware device? I don't see why you would do that with the storage, but.
I mean, yeah, for really small deployments, let's say you have tons of servers and you do have some equipment you could reuse. Yes, you can just use the software-defined storage stack from StarWind, and we actually just came out with a free version which has absolutely no restrictions to do that. So you can technically test the storage engine of the hyper-converged appliance free, and we will do honor production deployments of that. So I guess that would encourage the user to actually download it and see how it runs virtualized or non-virtualized.
So the next question is, does the appliance come with hybrid storage, or is it all flash, or can you get either one?
You can get either one, and right now we are redoing the hybrid configurations to come out with new higher capacity systems and bigger performance. So previously we used to have 2 lines, but we really tried to keep the capacity lower. Right now we see that a lot of customers start requiring bigger capacity for their robo locations. So let's say each location will just have 2 servers, but they do require something like 30 terabytes of storage. So we're designing the new hybrid environments with about 30 terabytes in mind.
Now, we all know that tape is not dead, and I understand you're using Veeam for on the backup appliance, but can the backup appliance send data to tape for long-term archival purposes?
Of course it can, yes. One more use case for the backup appliance is to do what's called disk-to-tape backup. So Veeam would send the data off to StarWind's backup appliance, thinking it is a physical tape. StarWind will quickly eat that backup and then send it off to tape without standing on the critical path of your production.
And when we start looking about, this is a hard question to answer probably, but what's the total cost of ownership and return on investment, TCO and ROI, with hyper-convergence versus VMware distributed virtual machine environments? Do you have, I know you probably can't answer that without lots more information, but do you have any resources that people can be pointed to for that?
I think what I can do, I do see the person who is asking the question, and what I'll do, I'll just try to send out that information as a follow-up to the webinar. So that's definitely a question where you need to work on it.
The other question is it's a relatively basic one, but it's an important one as well. What do the SL and XL lines represent? Like, what are the key differences between the small, I guess, probably the small, large, and extra large lines, right?
Exactly. Yeah. So the model line will change just a little bit. So the small are the tower servers for those organizations where they don't even have a rack. The L is the typical 1-unit system designed for more scale out than scale up, and XL are higher end systems designed for use cases like VDI and also bigger deployments where customer also wants to scale his storage and his compute up.
So do you have deduplication and or compression built into the systems, the appliances or the software?
Yeah, so it works with both appliances and software, but we would recommend to set up the software in a specific way to get the best results. And this is partially why some of it is better to use in the hardware models, because those are already pre-sized, pre-tested with all the firmwares or all the storage configurations and all the stripe sizes to get the best results for those.
Now you mentioned you can go to 64 nodes. but the question is, what customer range of needs can be met here? Like, I mean, are you targeting small companies, medium companies, enterprises? Like, what's the ideal target market for StarWind?
So ideal target market for StarWind, if we're talking about just the hyper-converged appliance, would be environments with a requirement to pack the maximum compute, RAM, and storage horsepower into a minimum number of nodes and get high performance. So what we found that these environments are enterprise branch offices and remote offices and SMBs, as both of them have high demands in simplifying their IT, and both of them are organizations which cannot go down. Because if it's, let's say, a car rental company, if their servers don't work in one of their rental locations, especially in the airport, it's a really big hit on the company reputation. If it's an SMB, they just took off, they cannot afford to lose one day of work because that may be a deadly strike for them. So our idea of getting them a fault-tolerant environment, which will not be hard-coded as scale-out only and provide maximum flexibility in terms of how they get it to their location, would be the best description of our customer.
Are separate licenses needed to enable full functionality, or is it an all-you-can-eat license up front?
Yeah, so the solution includes all features, so we don't have any feature limitations in our smaller models. I guess the only possible limitation would be the performance. Other than that, all appliances and all software will support our features. The only added thing would be virtual tape library functionality in the software. In the appliances, it is all included, so it only affects the software.
Okay. Two more questions. One, can you interface with Glacier or with other cloud storage services for, archival and things like that?
Yes, I cannot talk to that yet. We are doing a big announcement shortly, but there will be a possibility to interface with more than one cloud service provider. And I can just say that we are announcing in about 1 month.
Okay. And last question is, what is your service level agreement? I'm assuming for the hyper-converged appliance.
So for the hyper-converged appliance, we can go all the way up to 4-hour part replacement. And one more peculiar thing about any service level agreement getting with StarWind, you can choose if you need a 4-hour part replacement, because obviously the appliance we're doing is fault tolerant. So if you lost a drive, there is a high probability you can live with that through the night. But the engineer from StarWind will be remoted in to your environment within an hour to make sure that everything runs smoothly. And if there is any risk of service degradation, he will start recommending something immediately or even take action if he is granted to. And we are expanding that service, so soon it will also be empowered with support and recommendations from StarWind side on the configuration sizing and on the configuration load distribution. So there are more services coming, and all of them are currently designed to come in as standard options. So by default, StarWind will do all the recommendations, will reach out if something is wrong, and will, of course, always remote in to the environment to help the customer if something breaks.
Max, thank you very much for being our first presenter on our EcoCast today.